Hello students, welcome for another session of our class 8, chapter 9, areas of plane figures. In your previous classes, you have completed exercise 9.1 as well as exercise 9.2. Up to 3 problems we have completed. Now let us continue from there. Question number 4. Okay, what is given? This is the figure. In the adjacent figure consists 4 small semicircles. 4 small semicircles. What are that? This unshaded portion. This is like a semicircle 1. Here this shaded portion. This is 2. This shaded portion. This is 3. This is unshaded portion 4. 4 semicircles are there. Semicircle means half of the circle. 4 semicircles of equal radius. That means all the semicircles of radius are equal. Next again 2 big semicircles are there. 2 big semicircles. This is one big semicircle like this, and this is one big semicircle like this. That means here one line is there, no? With respect to this line, this is one big semicircle, this is one big semicircle. 2 big semicircles are there, 4 small semicircles are there. So in that shaded portion we have to find the area of the shaded region. What is the radius of each circle here? 2 big semicircles of equal radius of each 42 centimeters. Big semicircle's radius is given. Big semicircle radius is given. How much? 42 centimeters. So big semicircle radius is 42 centimeters. That means from here to here 42 centimeters. Understand? This is the big semicircle. This is the big semicircle. That means the diameter of the small semicircle. Diameter of the small semicircle is equal to a radius of the big semicircle here. Here both are there. This is the small semicircle. This is the small semicircle 3 and 4. Here this upper part is the big semicircle. And here this 1 and 2, these 2 are the small semicircles. This lower part is the big semicircle. So there are 2 big semicircles, 4 small semicircles are there. Here 2 big semicircles of equal radius, each 42 centimeters. The radius of the big semicircle is given what? 42 centimeters. So radius of big semicircle, which is given. Okay, given that radius of big semicircle is equal to 42 centimeters. Which is given. Okay, this is nothing but equal to the diameter of the small semicircle. So it is the diameter, right? So diameter of small semicircles are many are there? 1, 2, 3, 4. See here, if you take the big semicircle like this is the radius 42 centimeters. Now diameter of small semicircle. This completely transparent circle, no, this is the diameter from here to here, or here to here, or here to here, or here to here. These are all diameters of small semicircles. Both are same only, same 42 centimeters. Now, if you remove this and fix it here in reverse order, it will look like this. See now, I am drawing dotted lines. Like this. If you imagine like this, completing a circle now. I am completing a circle with this dotted line. Now this is one circle, this is one circle, right? 2 circles. If I fold like this, the shaded portion look like a full circle. The shaded portion look like a full circle. Okay. The shaded portion look like a full circle, right? Now the radius is how much now? The diameter is 42 centimeters. Now radius from this is equal to d by 2. No? Understand? D by 2. So now d is 42 by 2, which is 21 centimeter radius. Now the radius of the full circle, now it will become 21 centimeters. Now the shaded portion, when I imagine lines like this, the half portion is shaded, half portion is unshaded. Like this. this side and this side, these two will make half, these two will make half, right? That means it becomes like a half circle. That means full semicircle. Full semicircle. Now, area of the shaded region. Area of shaded region, which is nothing but area of the circle. Area of circle. Okay. Now, area of the circle formula we know pi r square. Pi r square. So, pi into r square, where pi is equal to 22 by 7 into r is equal to, just now we have got 21, so 21 square. Now 22 by 7 into r is 21 into 20. Now 7 ones are 7 threes are. Remaining is what? 22 into 21 into 3, that is 63. Now when you multiply with 22 into 63, so here 63 into 22. 2 3s are 6, 2 6 are 12. Again 6 2 bar. 6 8 3 bar. So 1386. 1386 centimeter square, which is the area of the shaded region. You have to imagine this total figure. By I complete with the dotted lines, it looks like a circle. This also, if I complete, it looks like a circle. Now half portion of this, half portion of this shaded. Here half portion is shaded, here half portion is shaded. Half portion of the two circles is unshaded, half portion of the two circles is shaded. So that means only shaded portion, if you merge with that, it will make a full circle. So area of the circle. So just look at the figure closely and imagine this shaded portion is making a full circle. Now the big semicircle radius is given 42, but the big semicircle radius will become the diameter of the small semicircle. So from that you have to get small semicircles are how many? 4, right? 2 semicircles will make 1 circle. Like that 4 are there. That means 2 circles now. 2 small circle, 1 big circle. Shaded portion I am telling you. The shaded portion is 2 small semicircles, 2 big semicircles. The shaded portion area is nothing but 2 semicircles becomes 1 full circle. 1 full circle. 1 full circle area is what? Pi r square. So radius we have to take. This you have to imagine as a diameter. Diameter by 2 will become the radius. Substituting that in the formula pi r square, we got 1386 centimeters square. That is what the area of the shaded region in this figure. Hope you all understood this figure. This question is very easy. Just observing the figure closely and making the relation with the radius what is given. Hope you all understood the solution. Let us move on to the next question now. Look at the question number 5. One more figure is given like this. The adjacent figure consists of 4 half circles. How many? 4 half circles and 2 quarter circles. Quarter circle means 1/4 of the circle. 4th part of the circle. Okay. 2 quarter circles. If OA is equal to OB is equal to OC is equal to OD, that all are equal to 14 centimeters. Here in the figure, O is here, A, B, C and D. Here OA, OB, OC and OD all are equal to how much? 14 centimeters. Forget about that. Half circles, quarter circles, number of quarter circles, number of half circles. Just focus on the figure. If you observe the figure carefully, you can only imagine the shaded region consists how much portion. Just see the shaded portion. Here this part is shaded, this part is shaded. If you remove this part and insert in it, this part, if you here the empty space, here the empty space. If you remove this and fix it, upper part will be filled like this. See. Now I am joining by the dotted lines. Now you can see like this. This portion, the unshaded portion, whatever is there, that is equal to this one. That means if I remove it and fix it here, it will be completed with half circle, half a circle. Otherwise, if you remove the upper part and fix it in the lower portion, so it will be looking like this half of the circle. So either upper part will be filled or the lower part will be filled. Upper part or lower part both. And if upside a half circle will come. If you make it downside, it will become a half circle. Right? That imagine. So just imagine like that upper portion and lower portion, or left side portion or right side portion. The unshaded portion, if you fill up with the shaded portion, it will be like a semicircle. Semicircle means half of a full circle. Only one semicircle will be formed with this shaded region. Okay? Only one semicircle. That means half a circle is the shaded region. That's all. So what is the radius? Radius is what from O to A or O to B or O to D or O to C. That all are equal. That is 14 centimeters. So radius is equal to R. OA is equal to OB is equal to OC is equal to OD. That is 14 centimeters. That means R is equal to 14 centimeters. That's all. Now area of shaded region. Only shaded portion, if you observe, if you fix it like this or like this, it will be making one semicircle. Semicircle means half of a circle. So area of semicircle. Only one semicircle you imagine. Semicircle. So semicircle means half of the circle. Half into area of the circle formula pi r square. Okay. Now half into pi means 22 by 7 into r means what? 14. 14 square. Now 1 by 2 into 22 by 7 into 14 square means 14 into 14 2 times. Right? Now 7 ones are 7 twos are, and this 2 cancel. What is remaining? 1 into 22 into 14. That's all. Again nothing is there. So 22 into 14. So simplify this. 14 twos are 28. Okay, 8 is here to carry somewhere. 14 twos are 28 plus 2 30. So this total is how much? 308 centimeters square. This is the area of shaded region. That's all. Don't confuse by reading the question. 4 quarter circles, 2 semicircles, half circles. This all doesn't matter. Just to look at the figure. This total description is what? This is the description of this figure only. No? Imagine the figure. That's all. Observe the figure closely. What is the shaded portion? What is the unshaded portion? If you complete with the dotted lines, you will be looking like a full circle, right? So half portion is shaded, half portion is unshaded. That's all. So half portion of the circle is nothing but semicircle. So area of the semicircle is nothing but half of the circle. So half of area of the circle. That's all. Radius is given. This part is radius, this part is radius, this part is all are equal. So substitute the value. Simplify it, you will be getting 308 centimeters square, which is the area of the shaded region. Hope you all understood. Observe the figure closely. That's all. Okay. Don't confuse by reading the 4 quarter circles, 2 semicircles, big circle, small circle. Do not confuse at all. Look at the figure. Look, understand what is the shaded portion, how it look like. Just write it. Hope you all understood this question. Let us move on to the next question now. See question number 6. In the adjacent figure, A, B, C and D are centers of equal circles. A, B, C, D are the centers of equal circles which touch externally in pairs, and A, B, C, D is a square of 7 centimeters. Then find the area of the shaded region. So look at the figure. Everything is related to figure only. How many circles? There are 4 circles. The centers of the circles are A, B, C, D. So this is the first circle with center A, second circle with center B, third circle with center C, fourth circle with center D. They are touching externally. That means from outside they are touching. One circle. Now circle A is touching the D and B. Circle B is touching the C and A. Circle C is touching the D and B. D is touching A and C. That means each circle is externally touching other 2 circles. So that if you join the centers of the 4 circles, a square is formed. Square means all 4 sides are equal. Now A, B, B, C, C, D and D. When we are joining the all 4 circles centers, a square is formed whose side is 7 centimeters. That means AD is equal to 7 centimeters, BC is equal to 7 centimeters, CD 7 centimeters, DA also 7 centimeters. Now you see from A to here. So this is A to here. here. That means half of AD or half of AB is nothing but radius of the circle. This portion, this portion. These are radius of the circle. This and this radius of the circle. All four circles are equal circles this side already. That means radius of all the four circles are equal. So why I am telling that radius? See, to find the area of the shaded region, the area enclosed by the four circles, that means in between the four circles, this portion is shaded. So which is inside the square but not in the circle. The shaded portion is not belonging to the circles, you will see. It's not belonging to the circles. This portion is belonging to the square only. Okay, that means the square portion, if you remove from that circular portions, you will get the shaded region. Okay, the square portion, if you remove from the circular regions, what are the circular regions in the square? How much part of the circle is covered? This portion. It is looking like a sector, right? This is also a sector. This is also a sector. This is also a sector. Like that, four sectors are there. These four sectors are belonging to the square, and the shaded region also belonging to the square. So to find out the area of the shaded region, we have to find the area of the sectors and area of the square. So now here radius, the side of the square will become diameter of the circle. Okay, side of square will become half of this radius, half of this radius completely. Side of the square is how much given? 7 centimeters. Now this will become radius. Now radius of circle. Radius of circle R is equal to, see, this portion is much only now. So total AB is 7. Total AB is 7, but I am taking only half portion. Why? Because this is the radius. Now radius will be 7 by 2 centimeters. Okay, radius R is equal to 7 by 2 centimeters. Now this for the solution, right? How many sectors are there? 4 sectors. So area of shaded region is equal to 4 sectors area, is 4 into area of sector minus ABC is what? A square. Area of square. Okay. Now side of the square we have, or radius also we have. So we can find out. Now 4 into area of the sector formula we know. Already it is given in the first class of our chapter 9. All quadrilaterals, triangle, ring, sector, circle, semicircle, everything is explained in the first part of our 9th chapter. Okay. So area of the sector formula x degrees by 360 degrees into pi r square. This is the area of the sector. Here what is x degrees? X is what? The angle subtended by the arc at the center point. That means here this is the arc, this complete is the sector. Now here the angle, here the angle, here the angle, here the angle. This is the angle that is x degrees, right? In the sector, the angle subtended by this arc is known as the angle of sector. As it is, you know that ABCD is a square. In a square, all angles are right angles. Square means all 4 angles will be right angles. Right angle means what? 90 degrees. That means the angle of the sector here is how much? 90 degrees. That means in place of x, we have to substitute 90 degrees. Why? Because it is a square, the angle of the sector is 90 degrees now. Minus area of the square formula, side into side. Now in the sector, angle is 90 degrees. Why? Because the sector, here you see these 4 sectors are from the square only. In a square, all 4 angles are right angles. That is why 90 degrees. Now 4 into x is 90 by 360 into pi means 22 by 7. R means what? The 7 by 2. 7 by 2 whole square. Minus side into side. Side is 7 centimeters is given. Now simplification. Say 4 into 90 which is 360 again. 360 by 360. Okay. Into 22 by 7 as it is. Here the 7 by 2 square is there. So 2 times 7 7 into 7. How much it is? 49, right? 7 into 7, 49. Let's see here actually what we have to do. The shaded portion is where it is actually. Shaded portion is inside the square. Inside the square. So we have to write it in reverse actually. Area of the square minus area of the 4 sectors. Area of the square minus area of the 4 sectors. We are writing it in reverse. Actually, from the square, the sector should be removed. From the square, the sector should be removed. So, area of the square should be written first and area of the 4 sector should be written back side. So, I will write this once again. So, area of the square minus actually. Area of the square minus area of the sector we have to do. So, I write it once again. So, area of the shaded region. Area of shaded region is equal to area of the square. Area of square minus 4 into area of the sectors. So 4 sectors are removed from the square, then only the shaded portion will come, right? Okay. Now here this is 4 into area of the sector. Here area of the square formula side into side. Okay. Now side how much it is? 7 centimeters. So 7 into 7 minus 4 into x degrees, that is angle of the sector which is 90 degree. So 90 by 360 into pi r square. Pi is 22 by 7. R is 7 by 2 whole square. Now 7 sevens are 49 minus here 4 into 90. Otherwise you can cancel 0 0 cancel. 4 nines are 36. Again divided by 36 is the left. Again 22 by 7 into here square means 2 times 7 by 2 into 7 by 2. So go for further simplification. 36 cancel, only one remains. Now here 1 7, here 1 7 will cancel. Remaining is here 2. So 2 1s are 2 11s are. Again here 7 is left, right? So I am cancelling this one also. Otherwise you can cancel this anything. 2 1s are 2 7. It will be 3.5. 7 divided by 2 it is 3.5. What is left? Only 11 and 3.5 is left this side. Here 49 is left. So I am writing 49 minus 11 into 3.5. 11 into 3.5. So 49 minus 11 into 5 is 55. So 5 here I carry. 11 3s are 33 plus 5 38. Okay. Understand? Now the decimal point is after 1 from the right hand side. Here 38.5. So 49 minus 38.5. So 49. So there is no decimal point. I am giving 2 zeros this side. Now 38.5. So what will be remaining? Here 0 taking 1 bar here. So 10 minus 5 is 5. Your point. Here it will be 8. 48 minus 38 is 10. So 10.5 centimeter square. 10.5 centimeter square. This is what the area of the shaded portion. Where actually shaded? Inside this, inside the square and outside the circles. This shaded portion is not at all in the circles. Okay, it is in the square but not at all the circles. 4 circles. Now like carom board, when you are playing caroms, all 4 kinds if you adjoining, if you keep together, between some space will be empty. You know the empty space. The 4 kinds if you arrange together, one circle will attach with other 2 circles like this. The space between that is shaded. So the center points when joined, a square is formed. Whose side is 7 centimeters. The shaded portion is nothing but area of the square minus area of the 4 sectors. All 4 circles are equal means all 4 sectors also equal. So area of the square minus 4 into area of sector. Area of sector formula is by 360 degrees into pi r square. Here x is what? The angle subtended by the length of the arc at the center. This is the arc of the sector, right? Here as these are the squares, angle of the angles in the square, all 4 angles will be right angles only. That means the area of the sector angle will be 90 degrees. So that is why we are substituting in place of x 90. So just side into side area of the square, 4 sectors, that is why we are writing as 4. Area of the sector formula x is by 360 degrees into pi r square. So So substituting the values and simplifying, we got the answer 10.5 centimeters square, which is the area of shaded region. Hope you all understood this problem. Only thing you have to concentrate on the figure first. Observe the figure carefully. Where the shaded portion is there. The shaded portion is in between the circles and also square. So that four parts of the circles, that are what? Sectors. That four sectors we have to remove it from the square to get the area of the shaded region. Hope you all understood. Let's see the next question. Look at the seventh question. In the adjacent figure, area of an equilateral triangle is 49 into root 3 centimeters square. In this figure, a triangle is there, which is an equilateral triangle. Equilateral triangle means you know that all the three sides are equal and all the three angles also equal. So the area of that equilateral triangle is given as 49 into root 3 centimeters square. Taking each angular point as center, each angular point means here A, B, C, these are the angular points. As center, a circle is described with the radius equal to half the length of the side of a triangle. That means this is one angular point, this is one angular point, this is one angular point. At that angular point as a center, a circle is drawn. Here this angular point, a circle is drawn. Here this one circle is drawn. Total 3 circles have been drawn to the vertex of the equilateral triangle. So the side of the triangle is how much? 7 plus 7 totally. Half of the side of the circle is radius of half of the side of the triangle. Sorry, half of the side of the triangle. That means side of the triangle is A to B, B to C, C to A. These are the sides of the triangle. Half of it from here to here. This is what radius of the circle. This is also radius of the circle. How much is given? 7 centimeters. Okay, in the figure it is given. That means radius of the circle is 7 centimeter. Side of the triangle is A to C, which is 7 plus 7, total 14. That side of the triangle is not required at all. Here area of the triangle already given in the question, so no need of finding the area of the triangle separately. Already it is given in the question, 49 into root 3 centimeters square. That is the area of the triangle. Okay. So we have to find the area of portion which is in the triangle but not in the circles. Which is in the triangle but not in the circles. What is that? In the triangle, this total portion is in the triangle, but in the triangle, this part you see, this part and this part. These three portions where the 60 degrees angle is written up. So why 60 degrees is written here? Since it is an equilateral triangle, all the three angles are equal. Each angle is about 60 degrees. So this sectors 1, 2, 3. These are the sectors of the circle whose angle is 60 degrees. 3 sectors we should remove it from the triangle. If you remove it from the triangle, the remaining portion which is not in the circles but it is in the triangle. This portion which is not in the circle is ending up to here only. Circle is ending up to here like this. This portion is circle portion. This portion is circle portion. This portion is circle portion. These three portions are belong to the circle, and this complete portion is triangle. So the portions which are belonging to the circles, that are sectors. So we have to remove the sectors. How many sectors are there? 3 sectors. The 3 sectors, if you remove it from the triangle, you will get the portion which we required actually. Okay. Area of the portion which is inside the triangle but not in the circle. Okay. Area of the portion. Area of the portion in the triangle, but not in circle. That is equal to what? Area of the triangle, area of equilateral triangle. What is the equilateral triangle? ABC. ABC minus 3 sectors. 1, 2, 3. Each sector consists of the angle of what? 60 degrees. So 3 sectors are there. 3 into area of sector. Area of sector. Let us do simplification. Area of equilateral triangle, it is given in the question itself, 49 into root 3 centimeter square. So 49 root 3 minus. Here area of the sector, we know the formula. Like that, how many sectors are there? 3 sectors. So multiply with 3. Okay. Next, afterwards, what we have to do? Area of the sector we have to multiply with the 3. Area of the sector formula, x degrees by 360 degrees into pi r square. Here x degrees means nothing but the angle subtended by the arc at the center of the sector. How much it is angle? 60 degrees. So we have to substitute 60 in place of x. So 49 root 3 minus 3 into, in place of x, 60 divided by 360 into, here 5, I am taking it as 22 by 7. So r is what? The radius. The radius is how much? 7. Radius is 7. Radius is 7. Radius is 7. So all the way, all the 3 circles are equal. So radius also same. So 7 centimeters. 7 square. So 49 into root 3 minus. Here I am simplifying this. 0 0 cancel. 6 ones are 6 6 are 36. Again 3 ones are 3 2s are. Again 2 ones are 2 11s are. Okay. Again what is remaining? 11 by 7 is remaining. After that 7 square, that is 7 into 7. This 7 also cancel. Now 49 into root 3 minus 11 into 7, that is 77. So we know the root 3 is an irrational number. The exact value of root 3 we cannot identify. So root 3 approximately we take after the decimal point only 3 digits we take. So we take 49 into root 3 value we are taking it as 1.732. So 1.732 is the root 3 value. Remember it. Okay. It is not exactly, it will come. So it will never end. It is an irrational number, which is a non-terminating, non-repeating decimal value. Okay. So that is why we take only 3 decimal places after the decimal point. 3 places we are taking. So minus 77. So multiply 49 into 1.732. Here 1.732 into 49. 9 2s are 80. Here 1 carry. 9 3s are 27 plus 1 28. Again 2 carry. 9 7s are 63 plus 2 65. Again 6 carry. 9 1s are 9 plus 6. It is 15. So with 9 multiplication is over. With 4 now. 4 2s are 8. 4 3s are 12. 2 here 1 carry. 4 7s are 28 plus 1 29. Again 2 carry. 4 1s are 4 plus 2 6. So adding this 8 the 16 1 carry again 8 again 14 1 carry again 8. So 8 4 8 6 8. The decimal point is after that 3 places from the right hand side. 1 2 3. So 1 2 3. That means 84.868. 84.868 minus 77. Okay. I am taking this 68 after the decimal point 68. Now I am taking it as 68 as 7. 8 7 I will take. Okay. So this we are 84.868. I am writing as 84.87. Okay. 87 minus 77. Now when you subtract it, you will be getting it as how much? 84 minus 77 is 7.87. If you further continue, root 3 value 1.732 and so many digits will come. If you write 3 4 5 digits again, if you compute, it may be differing about only decimal place. Okay, of 7.87 is okay. After that, some part difference in the decimal place value. That's all. So this is our area of the portion which is not in the triangle, not in the circles, but it is in the triangle. This 7.87 centimeter square. After this decimal point, if you go for further digits, you may get 7.828729 something you will get. Okay. So root 3 value exactly we do not know. We are taking it as 1.732. Why? Because it is an irrational number. Exact value of root 3 we cannot say. This is how we can find. Simply, you should look at the figure carefully. The portion which we need to find, where is it exactly? This is inside the triangle but not inside the circles. So how can you find the portion area? Area of the triangle minus area of these three sectors. If you remove the portion which we require, we can find out. So area of the equilateral triangle is given in the question 49√3 minus area of the three sectors. So substituting the values and simplification, we got the answer. So this is how we have completed our question number 7. Hope you all understood the class. So let us meet in the next class to continue the further problems of exercise 9.2. Thank you very much.